Hey everyone, Mr. Allen here. Just going to solve a couple of systems of equations here by substitution now. When we were taking this up in class, we originally tried to solve this by graphing and found that we weren't able to because the intersection point seemed to be between some values, some sort of a decimal answer. So we're looking to find a better way now. And substitution is what we decided is the better way. So when we look at these two equations, we see that y is the same as 3x minus 4. That's what that equation means. It's exactly the same for all points on the blue line. For all points on the red line, y is exactly the same as 2x plus 3. So what we're thinking about is the fact that we want that one point that's common to both. We want that one situation where y is equal to this, and the same y value is also equal to this. So what we're looking to do then is substitute into the equation y equals negative 2x plus 3 the expression 3x minus 4, which we know is also equal to y. So here's the y, we've replaced it, substituted in the 3x minus 4, and as I always stress, when I go to do a substitution, I'm putting it in parentheses just to ensure that if there is more going on, I can deal with it in turn. So straight substitution, y comes out, 3x minus 4 in parentheses goes in, the rest of the equation remains unchanged. And then it's a matter of just simplifying, working through here. I'm looking to isolate the x's, so I've added 4 to each side, and now I've got 3x on the one side, negative 2x on the other, so I want to add 2x to both sides to get 5x on the one side, just 7 on the other. Divide through by 5, and I have x is 1.4. Once I know that value, then I'm looking to substitute that value into one of my original equations to get the value for y. And so I chose, looks like this one, just because I happen to choose this one. And when I put the 1.4 in for x, I find negative 2.8 plus 3, which is 0.2. Of course, if I had substituted the 1.4 into the other equation, 3 times 1.4 is 4.2, minus 4 is y value of 0.2 as well. So I do get the same answer in both cases. So the point of intersection is 1.4 for the x, 0.2, so that is the point right there. So similarly here, second example, when I look at this one, it's not, the two equations are not in the form y equals mx plus b. So what I'm looking to do is determine which of the 4 possible variables, the x, the y in blue, or the x or the y in red, is the easiest to isolate. The x here in the red equation probably is because there's no coefficient, or again, of course, there's a negative 1 coefficient, but there's no numerical coefficient that I'll have to divide later on. And so I will rearrange this equation. I'm looking to isolate the x, so I've added x to both sides. Now the x is on the right, and I need to subtract the 5 to isolate the x entirely. I will then plug that value into my 2x plus 3y equals negative 4 equation. Now remembering what this is saying, that for all points on the red equation, x is exactly equal to 3y minus 5. And since we're looking for the one point from this red equation that is also on the blue equation, I can substitute the x value with the 3y minus 5 into the second equation here. And so again, brackets where the x was, plug in the 3y minus 5, and then as I simplify, I will multiply the 2 through the brackets, 6y minus 10. The 3y minus 4 hasn't been dealt with yet. Add the 10 to both sides and simplify by dividing through by 9. I get a y value of 2/3, which I will then use to find the value of x by subbing that y equals 2/3 into something. Now in this case I did choose to use the equation right here because it was fairly easy and I knew I hadn't made a mistake. probably a better idea would have been, as we did in the graphing video, go back to the original equations. Unless I made a mistake in rearranging the equation, though, this does work out just fine. So 3y minus 5 is x. We know y to be 2/3. And so when I multiply through, 3 times 2/3 is 2. Multiply the numerators if you need to. 6 divided by 3, which is 2, minus 5. We have an x value of -3. And so our point of intersection is this -3, comma, the 2/3 value for y. At this point, if you wanted to verify, you could also substitute the y equals 2/3 into the other equation. 2/3 in here, I have 3 times 2/3 is a +2. Subtract 2 is -6. Divide through by 2, I have an x value of -3, which of course is the same as if I sub into the other equation.